Okay, so today we're going to be talking about writing equations for lines. So first thing that we're going to do is up at the top of your notes. So we've got that slope is going to be our change of y divided by the change of x. This is your slope formula right here. So you got y2 minus y1 over x2 minus x1. And so the way that I do this is, again, it matters the order that you subtract the numbers in, and it matters that the y's are on the top and that the x's are on the bottom. So when we do slope, what I will do is I will stack the ordered pairs on top of each other, and that just kind of helps because now what I can do is I can subtract down my y column and put it on the top, and then I can subtract down my x column and put it on the bottom. And so this is just a kind of a good visual of that. This is going to be 2 minus 4, and then this one's going to be negative 2 minus 3. And so when I do that, just be careful with your calculation. Should get a negative 2 on the top, 2 minus 4, and then on the bottom I should get a negative 5. And whenever I get a negative divided by a negative, I want to change that to make sure that that's actually a positive. So that should be positive 2/5. With slope, it's best to keep things as an improper fraction rather than changing it to a decimal. With the second one, same thing. I'm going to stack the ordered pairs on top of each other. So I get 2, 4 there. And so again, I can go ahead and subtract down my y's, put it on the top, and then subtract my x's and put it on the bottom. When I do that, I get 1 minus 4 on the top, and on the bottom I get 2 minus 2. So I get negative 3 on the top and a 0 on the bottom. When I do that, I will end up with, you can't divide by 0. And so what this slope would be called is this is an undefined slope. Okay. The next thing that we have is slope-intercept form. So y equals mx plus b is pretty familiar to most people. And so y equals mx plus b is our slope and our intercept. The important letters for us is m is our slope. And just remember, if it's out of order, that the slope is always the thing that is in front of the x. So that's pretty important, not just to always think of it as the first number. It's always going to be the thing that's in front of the x. And then your b, that's your y-intercept. And again, that is the thing that has no variable. So it's the constant term. It's just the regular number that's by itself there, the one that's not with the x. So that's slope-intercept form. And then the other one that we have is point-slope form. This is your point-slope formula. And really the important part of your point-slope formula is the x and the y always stay x's and y's. Your m is still your slope, like it always is. And then your x1 is your x-coordinate, and your y1 is your y-coordinate. So the three things that I highlighted there, if you on your notes either highlight just those three things or underline them or circle or something, those are where we're plugging our numbers in for. We're never going to plug anything in for the regular x and the regular y. Those will stay regular x's and y's. So with the next one, so here we're going to graph. I'm going to show you a couple different ways of doing this. So with this first problem, I just have y is equal to 2/3 x plus 1. This one's pretty easy because y is by itself. And so I know that the number in front of my x is my slope. So my slope is 2/3. And then the number by itself is my y-intercept. So my y-intercept is 1. Your y-intercept is always your starting point. So from the middle of my graph, it tells me whether I start up or down. So since it's a positive 1, I'm going to start up 1. There's my first point. And then my slope tells me how I'm moving. So my slope is rise over run, so the top number tells me whether I'm going up or down. The bottom number tells me whether I'm going left or right. So from that first point that I made, I'm going to go up 2 and right 3. So I'm going to go up 1, 2, 1, 2, 3, up 1, 2, 1, 2, 3. And I can reverse the direction as well, where I go down 2, left 3. So down 2, left 1, 2, 3. Whoops. Down 2, left 1, 2, 3. And so here's what my line should look like. There's my line, graphing it. The second one that we have here, again, I always like getting y by itself because then I can understand what my slope and my y-intercept are, and that tells me more. So in these, I can distribute and get my y by itself then, and that'll help me to get it into slope-intercept form so I know what my slope and y-intercept are. So I distribute that -2, and then I can add the 3 to the other side. Just make sure you add it to the other constant term with no x. And so here's my equation, okay? Another way that you can do this, so if you have a graphing calculator, you can hit your y equals button, which is in the top left-hand corner, and in there you can plug in your equation. So I can plug in -2x minus 3. Your X button is just to the right of the green alpha button, just in case you can't find it. So you can plug this into your y is equal to. Then if you hit the second button and the graph button, it'll take you to a table, and you can let that table help you fill in, and then I can plot those ordered pairs. I usually like using about 5-ish points, just because then you'll know if one of your points is off, and I can fill in using that table. I can plug in, so 1, -1, -3, -5, and -7. And so then I can go ahead and plot these points. So -2, 1, -1, -1, 0, -3, 1, -5, and we should be able to kind of just see our slope happening here. And so there's my line. There you go. Same thing with this next one. I can distribute. Get y minus 5 is equal to -2x minus 4. And then I can add my 5 to the other side. And get y is equal to -2x plus 1. Again, same way. I'm going to make a separate video that shows you how to use Desmos, just in case you don't have a graphing calculator or you just want to double check yourself. Desmos is a super helpful thing that you can use online. So again, my slope here is -2. My y-intercept is 1. And so I can start up 1, that's what my y-intercept tells me. And then if my slope is -2, that means that I'm going down 2 and then right 1. Because if I wrote that as a fraction, it'd be -2 over 1. So when I do that, I can go down 2, right 1 over and over again. Again, just making sure that that is a negative slope. And I know that because it is going down from left to right. Whoops. That's better. There we go, and there we go. Okay? So again, that's just how we graph. Either using a table, again, in your graphing calculator, you hit the y equals button in the top left-hand corner. You can type in your equation, that right-hand side, and then you can hit second graph, and it'll get you to your table. So if I can write equations, I always, this point right here, I always want it to finish in slope-intercept form. So we may use our point-slope form at some point with the middle one and the bottom one, but we really want to always finish with y by itself. So with the first problem, I've got my slope is 3 and my y-intercept is -5. So since it gives me my slope and my y-intercept right away, I know that I'm just going to plug it right into y equals mx plus b. And know that my slope goes in for m and my y-intercept goes in for b. And so when I do that, I get y is equal to 3x plus, or I guess you could do minus 5 or plus negative 5, whichever way makes more sense to you, okay? But I'm just plugging them in. If I'm given the slope and the y-intercept, just plug it into y equals mx plus b. The next one, I'm given a point. So this is a point on the line and the slope. And so whenever I have something like that, I want to use my point slope form. Kind of why it's called point slope. So I can go, so that's y minus y1 is equal to m parentheses x minus x1. And then I can go ahead and plug in. So y minus, again, my y coordinate. So just as a little reminder, this is my x1, this is my y1, and my slope is my m. So when I'm plugging that y1 in, that's my y coordinate, which is 5. My slope is 2. And then my x coordinate is negative 1. And I on purpose, it should be minus a negative. I should have 2 subtraction signs there. That's actually right. Whenever I see something like this, the best thing to do is to get rid of the minus and negative as soon as you can, because it's confusing on whether that one is positive or negative when you have 2 signs in front. So the silly thing that I kind of do is I turn it into a giant plus sign. And so again, it's just a good reminder that A, on your notes, when you look at that giant plus sign, you're going to say, why is it a plus 1? I had a negative 1 up in my original problem. It's a reminder that it was minus a negative, and then I changed it. Now I can go ahead and get my y by itself, so I can get it into slope-intercept form. So there, and then I can add my 5 to the other side, and I get y is equal to 2x plus 7. And then the last one the one that we have here on this last slide, on this slide right here, I'm just given 2 points. And so if I'm just given 2 points, I want to find the slope first. So I'm actually I'm gonna take this -2, -1, and again, I'm gonna put it underneath. I like how that looked. There we go. So I just stack them on top of each other. I subtract my y's and put it on the top. Subtract my x's and put it on the bottom. And so when I do that, on the top I get 5 minus -1, and on the bottom I get 3 minus -2. Again, just be careful plugging it into your calculator, or you can go big plus sign on both of those because it's minus and negative, and that's going to give me 6 over 5. Okay? So if I'm writing an equation, and I have, this is my slope, so this is my m. And what I want to do is I want to write an equation. I'm going to use the slope, and then I get to choose one of the points. And in this case, I think, choose whichever one you think is easier. It doesn't matter which one you use. To me, it seems like it's going to be easier if I use the one that doesn't have negative signs. So I'm going to use the ordered pair 3, 5. So when I do that, I get y minus y1 equals m parentheses x minus x1. And so I go y minus, and then my y coordinate's 5, is equal to 6/5 parentheses x minus, and I should have done that in blue. And then my x coordinate ends up being 3. Now I can go ahead and distribute and then get my y by itself. So I get y minus 5 is equal to 6/5 x minus, so, oops. So that gives me 3.6, or as a fraction, that's 18/5. Yep. Then I can add my 5 over to the other side. Again, I like using fractions just in case. I know that it turns out as a as a terminating decimal, but just being comfortable with using fractions is always a good thing. So if I do negative 18 fifths plus 5 gives me 1.4, which is the same thing as 7 fifths. So you can do 7 fifths, you can do 1 and 2 fifths, or you can write it as 1.4. These are all the same thing. Okay? Just understand that they are all the same thing. Whichever way you want to write it, I'm always going to encourage using fractions. Okay? Horizontal and vertical lines. So when I look at an equation and I see only one variable, so this is x minus 3, this is y, or x is equal to negative 3 and y is equal to 2. I don't see two variables, and so when I'm graphing those, they end up turning into horizontal or vertical lines. And again, just really quickly, the easiest way that I think to teach this is if I make this into a T-chart, so if I do an XY table, if it's telling me x is equal to negative 3, it's telling me that x is always going to be negative 3. So my column that has x's in it is going to be nothing but negative 3's. My y for this equation, I don't have a y anywhere in here. So it doesn't matter what y is, so I can put whatever I want. So put 1, 2, 3. And so when I do that, negative 3, 1, negative 3, 2, and negative 3, 3, we're going to be three lines that end up being stacked on top of each other. And so then I can go ahead and put those together. So x is equal to any number is going to end up being a vertical line. Make sure that like this, the part that trips people up is this is my x-axis and this is my y-axis. If x is always a number, it has to cross your x-axis. So don't think about, that's sometimes where we get confusion, where we say, but the x-axis is horizontal. Why is x is equal to negative 3 not a horizontal line as well? It's because x is always negative 3, which means it has to pass through my x-axis. And then I can do the same thing over here with my y is equal to 2. If I would just make a quick T-chart, the equation's telling me y is always 2. Can't be anything else. And there's no x in this equation here. Oops. So I can make x whatever I want. So go 1, 2, 3. So ordered pair 1, 2, 2, 2, and 3, 2. I can connect them together. And there we go. There's my, again, y is equal to 2 is a horizontal line. Again, it is going through my y-axis, which makes sense. And then, again, the rule at the bottom of the page, y is equal to some number is always a horizontal line. X is equal to some number is always a vertical line. Okay?